Hello everyone, welcome to Manmaker. I am Ranjan Kumar Kalindi and today we are going to see some more questions of BEL Probationary Engineer, which is for electronics branch. So we are solving previous year question with details explanation. This exam held on 17 December 2023. Okay, so we see for PDF and more updates, you can join our Telegram channel. You can directly search through Telegram this name, Hardwork Limited. You will get this one. Otherwise, go to description box. Their link will be there. Just join this channel. Here you will get PDF notes for your question and class update. Everything you are going to get here. Okay. So as we solved already some question in a previous class, so today we are going to see some more questions which came in your previous year exam. Okay. So Thevenin theorem is applicable to which of the following network type? Okay, so Thevenin theorem is we have some theorems like in a network system we have Thevenin's theorem, Norton theorem, and we have superposition theorem, we have maximum power transfer theorem. Okay, so we have Thevenin theorems, Norton theorem, superposition theorem, maximum power theorem. So these all theorems are applicable only in uh, only for linear network. Okay, only for linear network. These all theorems are applicable only for linear network. Only for network. Okay. Apart from that, we have Television theorem. We have Television theorem. Okay, and this Television theorem, only this Television theorem is applicable for all kind of network, any network. Like we have linear network, linear, non-linear. Okay, then time variant, time invariant. Okay, active network, active or passive networks. Okay, active and passive network. So like that, Television theorem only is applicable for any kind of network. Apart from that, we have Thevenin, Norton, superposition and maximum power transfer theorem. These all are applicable only for linear network. Okay, so from here, your option 3 will be right answer. For an earth station transmitter, input power is 25 dB watt with a backup loss of 3 dB, a total branching and feeder loss of 3 dB and transmitted antenna gain of 25 dB. Determine the effective isotropic related radiated power. That is your EIRP we need to find. Okay. EIRP, effective isotropic radiated power, we need to find. So generally we have formula, this is Pn plus Gt minus LBO and minus LF. Okay, here P in is what? P in is your input power. This is your input power. Gt is antenna gain. Okay, this is your antenna gain. And LBO is back of loose, back of loss, and LF is what? It is feeder loss, feeder loss. Okay, so this is the formula for EIRP. We have power, input power, how much? To input power is 25. Okay, and GT we have antenna gain also, it is 25 dB. Then minus L backup loose we have 3 dB and feeder loose we have 3 dB. Okay, so it will be 50 minus 6, that is equal to 44 dB. What is your answer? Option D. Okay. Which of the following statement is true regarding the simplification of Boolean function using K-map? Okay, so in a K-map, generally we can group only adjacent ones in a power of 2. Okay, so this will be your right answer. How many RST restart instruction are there in 8085 microprocessor? So we have generally 8 instruction set, 8 RST instruction set in 8085 microprocessor. That will be from RST0 to RST7. Okay, we have RST0 to RST7 instructions in 808 microprocessor. And one more thing you need to remember, like this RST instruction is a 1 byte instruction. Okay, it is 1 byte instruction. Like that also question may come. Okay, apart from that, RST is used for this is used for interrupt. Okay, this is used for interrupt or jump service routine. Okay, just remember this thing. May question will come from this side also. It is used for interrupt or jump service routine. Okay, and it is 1 byte instruction. What is the effect of increasing the bypass capacitor value in a single stage BJT amplifier with emitter degeneration? Okay, so generally that bypass capacitor we are connecting with emitter in a parallel. Okay, it will be bypass capacitor. Just remember this thing, bypass capacitor. Each points are important. Okay, because they may ask anything. Bypass capacitor is connected parallel with emitter. Okay, just remember this point because maybe question will come, how bypass capacitor will connect with the emitter in single stage BJT amplifier. Then you should give answer parallel, not series. Okay, so if you see bypass capacitor formula with cutoff frequency fc, that is equal to 1 by 2 pi REC. Okay, so this is C is what capacitor and this is frequency. So whenever we are increasing capacitor value, bypass capacitor value, then the cutoff frequency will be decreased. Okay, cutoff frequency will reduce. Okay, just remember this cutoff frequency will reduce, and AC gain, or you can say voltage gain will increase. Okay, increase. Okay, so from here it will increase in voltage gain. This will be your answer for single stage BJT amplifier. What is the execution time of NOP instruction in 8085 microprocessor with a 3 megahertz clock frequency? So for execution time, to calculate execution time, that is TE, it is what? Number of clock cycle divided by clock frequency. Okay, this is the formula. So for each instruction, clock cycle will be different. Like for NOP instruction, we have 4 clock cycle in 8085 microprocessor. So it will be 4 divided by, we have clock frequency 3 megahertz, that is equal to 3 into 10 to the power 6. We can write this thing. Okay, so this is 4 by 3. We can write this is 10 to the power minus 6. We can write this thing. Then 4 by 3 is 1 by 3 into 10 to the power minus 6, or we can say 1 by 1.33 microsecond. Okay, so option 3 will be your right answer. In the context of channel capacity theorem, what role does channel bandwidth play in determining the capacity of communication channel? So, channel capacity theorem. Channel capacity theorem. Okay, channel capacity theorem, or it is also known as Shannon-Hartley theorem. Okay, it is also called Shannon-Hartley theorem. Okay, so if you see channel capacity formula, channel capacity, that is C, equal to V dot log to 1 plus SNR. Okay, this is the formula for channel capacity, or you can say channel capacity theorem, or Shannon-Hartley theorem. Okay, here B is what? B is your bandwidth, and SNR is signal to noise ratio. Okay, so you can see here this channel capacity C is directly proportional to bandwidth. Okay, so we can say this option like in the context of channel capacity theorem, what is the role of channel bandwidth play in determining the capacity of communication channel? So this channel bandwidth is directly proportional to channel capacity. From this formula or this theorem, we can say like that. Okay. For an undamped second order system, the damping ratio is. So damping ratio, okay, damping ratio is lie between 0 to 1. Okay, 0 to 1 it will lie. Apart from that, just remember this thing, whenever damping ratio is equal to 0. Okay, whenever damping ratio is 0, then system is undamped. Okay, system is undamped. System is called undamped. When this damping ratio is equal to 1, then system is critical damp. Critical damp. When damping ratio is less than 1, then system is underdamped. Under system is called underdamped. When damping ratio is greater than 1, then system is called overdamped. Okay, so just remember these all points. Okay, see, whenever we are practicing previous year question, that not means we have to see only what kind of question they have asked in last year. We have to also see some like important points, how means what kind of question they may ask for the next session. Like that, if they will set same pattern, same syllabus, same label will be there, then they will ask from like this question only. Means when system is called critical damp, then option will be there when damping ratio is 0, greater than 1, equal to 1. Then you have to give answer. It is equal to 1. So like that you have to make a note, make a point for every question. So it will be helpful for your next exam. Okay. The bandwidth of RLC parallel circuit is. The bandwidth of RLC parallel circuit. We have RLC, resistor, in inductor and capacitor parallel circuit. So if you see the relation for RLC parallel circuit with bandwidth. So bandwidth is equal to what? Bandwidth is F by Q, where F is what? F is your frequency and Q is quality factor. Okay, this is quality factor. So from here we can say bandwidth is directly proportional to frequency, and bandwidth is inversely proportional to quality factor. Okay, which is in your option, inversely proportional to Q factor or quality factor. So if they will ask with respect to frequency, then bandwidth is directly proportional to frequency. Like that you need to give answer. Closed loop control system, the characterized by which of the following? So in closed loop system, okay, in closed loop control system, it has some characteristic. Like in closed loop system, it uses feedback. It uses feedback uh, to reduce system error. Okay, to reduce system error. Okay. and it provides more accuracy. It's provide more accuracy compared to open loop gain. Okay, and also it is more stable. It is more stable, and it reduce sensitivity. Sensitivity. Okay, it reduce sensitivity. So just remember these all points. Okay, it uses feedback to reduce system error. Then it is more accurate compared to open loop control system, and it is more stable compared to open loop control system, and it is more stable. That's why it reduce sensitivity. Okay, so from here we have only this option: use of feedback to reduce system error. So only two is right answer. Which of the following is correct binary representation of hexadecimal 3, and 9? This is a hexadecimal representation. We have to find respective binary. So 3, how we are writing 3? This is 0011. This is a 1010, and 9 is what? 1001. This is your binary. You know already, I think, 000, this is 0, then 0001, this is 1, 0010, this is 2, 0011, this is 3, 0100, this is 4. So like that, 1111, this is F or 15. Like the table is there. I think you know. In a phase modulation, what happens to the phase of carrier wave when the amplitude of the modulating signal is 0? Okay. So phase modulation is what? Phase modulation. In this process of phase modulation, the characteristic of a phase of carrier is changes or varies according to the modulating signal. Okay. If you see the phase modulation general formula, it will be phase of this, and this is phase node plus kp m of t. Okay, where this phi 0 is what? Initial phase of carrier wave. Okay, and this kp is your modulation index of phase modulation, and this mt is what? M of t is modulating signal. Okay, modulating signal. Okay, so when modulating signal, as they asked, when what happened to the phase of a carrier wave when the amplitude of a modulating signal is 0? So when modulating signal is 0, then there is no variation in phase deviation. It will be always constant, remains constant. Okay, so this will be your answer. Okay. Which biasing method provide the best thermal stability of a bipolar junction transistor, that is BJT? So we have biasing in BJT like base biasing, emitter feedback biasing is there, controller feedback biasing is there, and voltage divider biasing is there. So among these all, we have voltage divider bias, which is best which provide best thermal stability. So voltage divider bias will be your right answer. Okay, so like that question, it came in your exam. Okay, and according to this exam pattern of your previous year and whatever syllabus I discussed in the last class, based on that only I have some practice set for your practice set or PDF for your probationary engineer exam. If you want, you can take this one. If you take and if you practice this question, you are going to complete same level of question, and with the same pattern, with like this details explanation will be there with solution. Okay, so if you cover that one, you will feel more confident about your exam. Okay, here you are going to get around 500 technical question and 125 non-tech question. Okay, so if you want this one, just drop a message here, or just do a WhatsApp, and you will get this PDF. Okay, and anyhow, your probationary engineering class is already going on. Okay, So for today, this much only. We'll continue next in the next class. Okay. So if you like the video, just hit like on a button. Kindly share with your friends, and if you're not subscribed my channel, just subscribe the channel and press bell icon. Thank you.